Hello everyone, welcome to Apex Mathematics. My name is Bino. In this video, I'm excited to share with you the following question, which is based on geometric number patterns. And the instruction reads that a convergent geometric series consisting of only positive terms has first term A, constant ratio R, and nth term Tn, such that the sum of Tn from n is equals to 3 up until infinity is equals to 1 over 4. Question 3.1. If term 1 plus term 2 is equals to 2, write down an expression for A in terms of R. So we are told that term number 1 is equals to A, and that the constant ratio is R. And for a geometric pattern, we have Tn is equals to A multiplied by R raised to the power n minus 1. We are given that term number 1 plus term number 2 is equals to 2. Term 1 is already given as A, so there is nothing we can do about that, but we can do something about term 2. So term number 2, in the place of the n, we have 2 is equals to A, the first term, multiplied by R, the constant ratio, and in the place of the n, we have 2 minus 1, and this will be equal A multiplied by R raised to the power 2 minus 1. 2 minus 1 is equals to 1. So term 2 is equals to A multiplied by R. We substitute into this formula. So term 1 is A, term 2 is A multiplied by R, and this is equals to 2. We have A both sides of the positive sign, so we take the A as our common factor. We have A into 1 plus R, and this is equals to 2. We divide both sides of the equation by 1 plus R, and on the left hand side, the 1 plus R will cancel out each other, or they will divide each other, and our A in terms of R will be equals to 2 divided by 1 plus R. Moving on, we calculate the values of A and R. The tricky part about question 3.2 is that the sum starts from n is equals to 3 up until infinity, and this will be equals to 1 over 4. So when we use the sum to infinity, n has to start from 1 up until infinity, not from 3. So the formula for sum to infinity from the formula sheet, we have sum to infinity is equals to A divided by 1 minus R, and the sum to infinity, like I said, is equals to all the sums from term number 1. We also add term number 2 plus term number 3 plus term number 4 plus term number 5 plus, and this will continue up until infinity. Since we are told that this is a convergent geometric series, the terms closer to infinity will be so small that they will almost be equal to 0. I mentioned that the tricky part is that our n starts from 3 and not 1. So it includes the terms from 3 up until infinity, and the 1 over 4 excluded the term 1 and the term 2. But we have been given the value of term 1 plus term 2. So sum to infinity will be equals to the term 1 plus term 2, which is equal to 2, and the sum from n is equal to 3 up until infinity was given as 1 divided by 4, and 2 plus 1 over 4 is equals to 9 divided by 4. So now that we have the sum to infinity from n is equals to 1 up until infinity and not 3 up until infinity, we can use our formula. So our sum to infinity, we just determine that is equals to 9 divided by 4, and our a is in terms of r. So we have our a in terms of r. So this formula for sum to infinity will be equals to, so we have that the a is a fraction in the form of 2 divided by 1 plus 3. So let's rewrite our formula using the traditional division sign. So if a divided by 1 minus r, we will substitute the 9 over 4 later on. For now, we have the sum to infinity is equals to the a is equals to 2 divided by 1 plus r, and this is divided by 1 minus r. Our sum to infinity will be equals to, so suppose that we had a divided by b over c, we can change the division sign. So we can change that division sign to multiplication sign. And when we do, the c, which was a denominator, will now become a numerator, and the b, which was the numerator, becomes the denominator. So we have 2 divided by 1 plus r. We change that division sign. So this division sign, we change it into multiplication sign, and remember that the 1 minus 3 is divided by 1. So the numerator will become the denominator, and the denominator will become the numerator. So we'll have 1, and in the denominator now we have 1 minus r, because we changed the division into multiplication. Our sum to infinity will be equals to that 2 multiplied by the 1 in the numerator will be equals to 2, and in the denominator we have a result of the difference of 2 squares. So if we had a plus b multiplied by a minus b. There is no need for us to expand the whole thing. We can just multiply because we have a positive and a negative on the other parenthesis, and we have the a and the a and the b and the b. We can just multiply the a and that a, and we'll have a squared, and the positive multiplied by that negative will be equals to a negative, and we also multiply the b with that b, and it will become b squared. Remember that we only do this if the two brackets are the same, except that the other one, the sign in the middle has to be positive, and the other one, the sign in the middle has to be negative. So we are going to multiply that one with that one, and 1 squared is just 1, and the positive multiplied by the positive is negative, and that r multiplied by that r will be r squared. So now we can substitute the 9 over 4 where there is sum to infinity. So in the place of the sum to infinity, we substitute 9 divided by 4, and this is equals to 2 divided by 1 minus r squared. And from here, we can cross multiply, and the 9 will be multiplied with the 1 minus r squared, and this will be equals to the 4, we multiply it with the 2. Let's distribute the 9 inside the parentheses. So 9 multiplied by 1 is equals to 9, and 9 multiplied by negative r squared is equals to negative 9r squared, and 4 multiplied by 2 is equals to 8. So we have 9, but let's move that 8 from the right to the left, and it will change sign to negative 8, and this will be equals to, we move the negative 9r squared from the left to the right, it will change sign to positive 9r squared. On the left hand side, 9 minus 8 is equals to 1, and the 1 will be equals to 9r squared. We solve for r by dividing both sides of the equation by 9, and 9 divided by 9 is equals to 1, so they will cancel out each other. So we have 1 divided by 9 is equals to r squared. To solve for r, we are going to introduce the square root both sides of the equation. The square root of 1 over 9 will be equals to 1 divided by 3, and the square root of r squared is equals to r. So our r is equals to 1 divided by 3. So now we are going to substitute the r is equals to 1 over 3 into this a formula in order for us to determine the numerical value of a. Our a will be equals to 2 divided by 1 plus r, but in the place of the r, let's substitute the 1 over 3. And our a will be equals to 3 over 2. And 3 over 2 can also be expressed as 1,5. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.